So we're looking at number 12 on page 17. This question is asking us to find the projection of V onto U. It's pretty straightforward formulaically, because it's really just asking us to find the dot of U and V divided by the magnitude of U squared, and then multiply by the vector U, right? So it's taking the component of the projection of U, so the magnitude of the projection of V upon U, I should say, and then incorporating that into the direction of U to give us a sense of what the vector is. All right, so U dot V, we're talking, if you want to write it in component form, you could, but you could also just pull the pieces out and go with it that way. So the coefficient of I is 1, so 1 times 3 plus coefficient of J, 6 times negative 2. I'm just doing it in UV order, even though it doesn't make a difference for the dot product. All right, so that would give a result of, so we're taking 3 and subtracting 12 from it, so negative 9. All right, so the magnitude of U squared one of the shortcuts that we learned is that if you want to find the magnitude of U, well, the magnitude of any vector squared, you could always just dot a vector to itself. All right, so in this case, the vector is 1, 6. So it'd be 1 squared plus 6 squared, which would give a result of 37. So now what I want to do is I want to use this as a scalar. All right, so if I want the projection of V upon U, I'm looking at negative 9/37 multiplied by the vector U, which would be 1/6 in component form. So I'd be looking at negative 9 over 37, negative 54 over 37.